So yesterday we looked at one variable inequalities. Today we're going to look at two variable inequalities. So we are going to dive a little bit more into this being like a linear equation or linear inequality. So today I do have graph paper. It is attached to this assignment. If you are able to print it out, you can. If not, you can just sketch it, and that's fine too. In the last lesson, you learned how to use an inequality with one variable. You'll also just discover that a one variable inequality can have infinitely many solutions, and that these solutions can be represented on a number line. So when we represent on a number line, we can go from that number to infinity. So once you can go to infinity, it's infinitely many solutions. But what if an inequality has two variables? What is the solution to a two variable inequality? How could these solutions be represented graphically? So first of all, it says graph y equals negative 2x plus 3. So we're going to start by graphing the y-intercept, which is positive 3. So on the y-axis, we're going to put a dot at 3. And then the slope is negative 2, which means we're going to go down 2 and to the right 1. Down 2 and to the right 1. And you can keep doing this if you want to, but after you get about 3 points, you can also you are also able to just draw your line. It's up to you. I like to do all the points. Okay. Now here's your graph. Not perfect line, but it's okay. Make sure there's arrows though, because it is a line. Now, is the point negative 1, 5 a solution to the equation y equals negative 2x plus 3? Well, let's look. Negative 1, 5. 1, 2, 3, 4, 5. That's right here. So yes, it is a solution. We can tell by looking at the graph. So yes, it is a solution. On the graph, it is a point on the line. Now, how can we tell by looking at the equation? Well, we can plug x and y into the equation and see if it checks out. So let's do that. So the x is negative 1 and the y is 5. So where it says y right here, I'm going to plug a 5 equals negative 2 times negative 1, because where there's an x, I'm plugging in negative 1, because that's my x right there, negative 1, plus 3. Negative 2 times negative 1 is a positive 2, so 5 equals 2 plus 3. 2 plus 3 is 5. 5 equals 5. It checks out. That's how you know if something is a point or not. Now, is the point 2, negative 1 a solution? So let's see. 2, negative 1 is a solution. Is the point 0, 0 a solution? So 2, negative 1 is a solution. Yes. Is 0, 0 a solution? 0, 0. Is it a solution? It's not on the line. No. But let's double check in the equation. So we checked on the graph. Let's double check on the equation. So for 2, negative 1, it would be negative 1 equals. So I plug negative 1 in for y up here. Negative 2 times x is 2. So 2 plus 3. Negative 1 equals. Negative 2 times 2 is negative 4 plus 3. Negative 1 equals. Negative 4 plus 3 is negative 1. So it checks out. Now it says 0, 0. Let's plug 0, 0 in and check. So 0 equals negative 2 times 0 plus 3. 0 equals negative 2 times 0 is 0. 0 plus 3 is 3. Does 0 equal 3? No, meaning it is not a solution. Hey, what determines if a point lies on the line? What is the difference between the points on the line and the points not on the line? So first of all, what determines if a point lies on the line? A point lies on the line if the x and y fit into the equation. Essentially, if the x or input can go in and generate the output or y. That's how you check if a point is on the line. And it's how it makes sure that a point is on the line. The x and y both check out. Now, what is the difference between points on the line and points not on the line? Points on the line make the equation true. Like this one right here, it makes the equation true. While points on the line, or no, while points off the line make the equation false. Here, that is not true. So it makes the equation false. Okay, let's keep going. In problem 1, you found that the points on the line are the only points that make the equation y equals negative 2x plus 3 true. But what if you want to graph the solutions for an inequality? Y is greater than or equal to negative 2x plus 3. How will that graph differ from the graph of y equals negative 2x plus 3? Consider this question as you follow the steps below. First of all, test out the following points in the inequality. So let's test out 0, 0. We do 0 is greater than or equal to negative 2 times 0 plus 3. Negative 2 times 0 is 0. 0 plus 3 is 3. Is 0 greater than or equal to 3? 0 is not greater than or equal to 3, so this is not true. So 0, 0, not a good one. And what about 1, 5? Let's see. So 5 is greater than or equal to negative 2 times 1 plus 3. 5 is greater than or equal to negative 2 plus 3. Negative 2 plus 3 is positive 1. 5 is greater than or equal to 1. Is that true? Is 5 greater than or equal to 1? It is. So that one checks out. Negative 4, 6. 6 is greater than or equal to negative 2 times negative 4 plus 3. Negative 2 times negative 4 is a positive 8. So 6 is greater than or equal to 8 plus 3. 8 plus 3 is 11. Is 6 greater than or equal to 11? No, it's less than. So that one's not true. Negative 2, negative 3. Let's try this one. So negative 3 is greater than or equal to negative 2 times negative 2 plus 3. Negative 2 times negative 2 is 4. So 4 plus 3. 4 plus 3 is 7. Is negative 3 greater than or equal to 7? No, it's less than. So this one doesn't work out. Next one. Negative 7 is greater than or equal to negative 2 times 6 plus 3. Negative 7 is greater than or equal to negative 12 plus 3. Negative 7 is greater than or equal to negative 9. Is that true? Yeah, negative 7 is bigger than negative 9 because it is a smaller negative than negative 9. So that is true. So we have 2 true statements right now. I don't think there's any. Oh, there are 2 more to do. Let's see if we get any more. So 2, negative 1. We have negative 1 is greater than or equal to negative 2 times 2 plus 3. Negative 1 is greater than or equal to negative 4 plus 3. Negative 4 plus 3 is negative 1. Is negative 1 greater than or equal to negative 1? Well, yeah, they're equal to each other, so it counts. And last but not least, negative 1, 5. So 5 is greater than or equal to negative 2 times negative 1 plus 3. 5 is greater than or equal to, this is 2 plus 3. 5 is greater than or equal to 2 plus 3 is 5. They're equal to, so they check out. So we have 4 true statements and 3 untrue statements. So we're going to plot the points that work on the graph to the right. Also, we're going to draw the line for the equation. Where are the points in comparison to the line? So let's see. So first we're going to plot the points and then we'll draw the line. So the first point that works is 1, 5. So 1, 5. I'm going to plot that. Another point that works is negative 7, negative 9, negative 7. Oh, no, sorry. 6, negative 7. I was looking over here. 6, negative 7. So 6, negative 7 is a point that works. And then up here, 2, negative 1 works. 2, negative 1. And negative 1, 5 works. So those work. Now, let's plot the line. So we start at 3. We go down 2 over 1, down 2 over 1. And we're we're going to draw the line. Now, the points that worked, and I know I didn't draw the line, where are the points in comparison to the line? They're either on the line or they're above their line. They're up or above the line. Heidi asks, what if I change the inequality y is less than negative 2x plus 30? Now what would the graph look like? Well, if it's less than, then the points are going to be under the line. And since there's no equal to, they won't be on the line. So if I were to graph this inequality correctly, it would be a solid line, solid because it's equal to, and we're going to shade up. We shade up because every point above this line is correct. So let's look at number 5 and we're going to practice this. It says graph the inequalities below on graph paper. For each inequality, graph the boundary as either a solid or a dashed line and shade the region that makes the inequality true. Check your answers in Desmos. So before we start, when we do this, solid or a dashed line, solid line is for less than or equal to and greater than or equal to. Dashed or dotted lines are for less than or greater than. You shade up when you have greater than or equal to or greater than. You shade down when you have less than or equal to or less than. So that's going to help us out a little bit. Let's start off with our first one here, which is y is greater than negative 1/3 x minus 1. So we're first going to start off by plotting our y-intercept of negative 1. So I plotted negative 1. And then we're going to go down 1 over 3. Down 1 over 3 because negative 1/3, down 1 over 3. And it's rise over run, so down 1 over 3. You can do the opposite by going up 1 to the left 3 if you would like as well. Don't look at that one. That was a bad point, but it might help us out. Now, because this is greater than, but not equal to, we do a dashed line or dotted line. You still have arrows on the line. And since it's, so remember, if greater than, no equal to, it's dashed, because that tells you that the line is not included in the answer. And then, since it's greater than, we start at the line and we shade up. You shade the whole region above the line. Your shading does not have to be perfect, so don't worry about that. So let's look at the next one. And I usually like to on my equations, and maybe I should do that for this one too. Y equals negative 2x plus 3. On my graphs, I like to write what I did. So if I go back to the graph, I can remember what I was looking at. So this is going to be y is less than or equal to 4x plus 2. So already I know it's going to be a solid line because it is equal to, and since it's less than, I'm shading down. And sometimes it helps to take those notes as you go. So first off, we're going to start at 2 on the y-axis, and then my slope is 4. So I'm going to go up 4 over 1 because it is a positive 4. Up 4 over 1. I can also go down 4 to the left one. So I can do the opposite of what I just did to get the same answer. Now it is a solid line, so I'm going to draw a solid line through these. And it says to shade down. Now, shading down, I start at the line and go down. And once I have that, I know the region I'm supposed to shade in. Remember, shade down from the line. Not to the left, but down from the line. All right, next one. Y is less than 5/2 x plus 3. Y is less than 5/2 x plus 3. Since it's less than, we're going to shade down. And since it doesn't have the equal to, it's going to be a dotted or dashed line. All right, let's start plotting this. So we start at 3, and then it's 5/2, so we go up 5 over 2. 1, 2, 3, 4, 5 over 2. Now I can't go up 5 over 2 again, so I can go down 5 to the left 2. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 2. Now I said this is a dashed or dotted line, so you got to put that in. And this time we are shading down as well. So we're going to start from the line and go down, which means we're shading this region right here. Okay, one more to do. Let me grab another piece of graph paper and let's go. Now there is an issue with graphing this one straight off the bat. And the issue is that it's not solved for y first. So we first have to solve for y. To solve for y, we're going to subtract 2x on both sides. We'll get negative y is less than or equal to negative 2x plus 5. I want it in so it looks like y equals mx plus b, that slope-intercept form. Now this has a negative in front of it, so I'm going to divide everything by negative 1, just like it had a number in front of it. And since I divided by a negative, this is going to switch to greater than or equal to. This will become 2x, and this becomes negative 5. So now that I have that, let's write that up here. We know this is going to be a solid line because of the equal to, and we know since it's greater than, we're shading up. So let's start with negative 5. 1, 2, 3, 4, 5. Negative 5 on the y-axis because that's my y-intercept because it's my b. And then my slope tells me to go up 2 over 1. Up 2 over 1. And once you have a general gist of which way this is going, you can draw your line. Now again, start on the line, shade up. So you shade that area right there. And that is how you graph linear inequalities. Tomorrow you are going to have an activity showing you how to graph linear inequalities on Desmos, so definitely look at that, and I hope you have a wonderful day.